Hey, Algebra 2. We're going to take a little baby break from factoring to talk about section 4.5, where we're solving quadratic equations, by using square roots. Okay, so we're going to learn about square roots in this section. We're going to start off by, how can we simplify some square roots? What can we do with square roots? And then we'll go ahead and use them to solve our quadratic equations. Okay, so just to kind of refresh you on how to do a square root and what does that mean, when we take the square root of a number, x, we ask ourselves what number times itself gives me x. Every time you see a square root, that should be the first question that booms into your mind. If I see square root of, if I see square root of 16, one number times itself is going to give me 16, that's 4. And also negative, right? Negative 4 could also be an answer here. What about 25? What square root of what number, what number times itself gives me 25? That's going to be 5, and also negative 5, right? And we'll talk about where these negative answers will come into play. But for now, technically, we only use like the positive because we call that the principal square root, and that's just kind of the first one that comes to our mind. Okay, we'll come back to that negative in a little bit. But for now, just the basic square root of something is going to give me what times itself, gives me the inside of the root. Sometimes you're going to see the square root called a radical. That symbol, this little check mark looking thing with the house, is called a radicals. Okay. And it's good to just know that not all numbers are going to have a nice square root. Like if we think about the square root of 15, if you put that in your calculator, you're going to get a really huge decimal, or a really long decimal, sorry. All right, so now there's things that we can do with square roots. Okay, properties of square roots. Here we're going to use a and b, just so you know a and b are both positive numbers. It only works when they're positive. Okay, so product property tells me that when I have a times b inside the radical, I can separate that with the multiplication operation in between. Quotient property tells me something similar. If I have a divided by b inside the radical, quotient property says I can separate with the operation of division. Okay, we're going to apply that in the examples below, but I want to kind of make this clear right now, right this second. There is absolutely nothing that says addition property or subtraction property. So I never, ever, 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 ever want to see this from you guys on your homework or on the checkpoint, because I will cry tears of blood. And you don't want to see your math teacher do that. Okay, so don't just fight the temptation. If you're wondering why is that not true, do an example. Let's think about square root of 10 plus the square root of 6. If this were true, then this were to be equal to square root of 16, which is 4. But if you do this right here in your calculator, you do not get 4. Okay, so just don't do it. Just don't do it. Big no-no. Okay, let's do some examples. Simplify the following square roots. Okay, we're going to use the product property a lot for these first two, and in general for simplifying radicals, for simplifying square roots. Okay, so to simplify square root of 80, what it wants me to do is see if I can factor anything outside of the radical. So ask yourself, this is kind of the nicest way to go about it. Think about all your perfect roots. There's 1, 4, 9, sorry, perfect squares, not perfect roots. 16, 25, 36, 49, 64, 81, 100, and so on and so forth, right? Because this is 1 squared, this is 2 squared, 3 squared, 4 squared, 5 squared, 6, 7, 8, 9, and 10. It would be advantageous of you if you have this already committed to memory, and maybe even go a little further, go up to say like 15 squared, I would say is a good place to, you don't have to keep going further than that. You can if you want to just not have to ever calculate that stuff again. but it would be quicker to be able to know this stuff and commit it to memory than have to calculate it every single time. And the reason why is because here, the nicest way to go about simplifying this is asking yourself, is there a perfect square? What's the biggest perfect square that divides into 80? Well, if we check, we know it's got to be less than less than 81. 64 goes into 80? No. 49? Nah. 36? Nope. 25? Nope. 16 does though. I can rewrite 80 as 16 times 5. So I can do that underneath the radical. I can rewrite square root of 80 as the square root of 16 times 5. Product property says I can write this as 16 times square root of 5. Square root of 16 times square root of 5. And now this is nice because we know the square root of 16 is 4 times the square root of 5. So here is our simplified answer, 4 radical 5. Not too bad, right? Let's go ahead and do part B. 10 times rad 10 times rad 15. The way that we can do this one, you know, there's no perfect square that divides into either of these. So we got to think of a different approach. The other thing you could have done here in part A that we'll do in part B is you could have done a little factor tree, or you could have just listed out all the factors and then went from there. So let's do that here. In 10, I know that's 2 times 5. In 15, I know that's 3 times 5. Oh, and now I can just combine them according to the product property. So I can do 2 times 5 times 3 times 5. And I can reorganize it a little bit. I can say 5 times 5 times 2 times 3. Oh, yay. So you're trying to be strategic. You're trying to get that perfect square under there. So 25 times 6. So now this is square root of 25 times square root of 6. Square root of 25 is 5. Radical 6. Okay? So you can either do a factor tree or you can do it with the perfect square method. You can factor out in pairs. I know that is also a common technique as well. Whatever makes the most sense to you. Okay, do it that way. Let's do some of that quotient property now in these bottom examples. Okay. Oh, spoiler alert, we're gonna have to rationalize in a little bit, but not right now. Quotient property says here that I can rewrite this as the square root of 9 divided by the square root of 64. And that's nice because we know the square root of 9 is 3 and the square root of 64 is 8. And that is simplified. Last one for these examples, I can rewrite this as square root of 11 over square root of 25. And the quotient property tells me that I can rewrite this as the square root of 11. There's no nice square root of 11, but square root of 25 is 5. So there's my answer. Sometimes you'll still have a radical like you had up there, but you know, that's okay. What we do want to avoid, and we'll talk about in the next video, is having the radical in the denominator. And the reason why is because having radicals in the denominator, that kind of ruins our number sense a little bit. We don't really know off the top of our head what square root of 5 is, but we know what 5 is, right? We know 5 is. 5 is a good old friend of ours. Square root of 5, not so much. It's like 2 point something, okay? So that's what we're going to rationalize in the next part of these videos. So meet me there.